Hi everyone. Today we are going to see coefficient of variation in numerical and statistical analysis. Myself Josmi Joseph, Assistant Professor of Computer Science. In statistics, dispersion is the extent to which values in a distribution differ from the average of the distribution. We have seen various measures of dispersion in the previous lecture. Measures of dispersion is divided into two. First one, absolute measure of dispersion, which gives the amount of variation. Examples, we have studied standard deviation in the previous lecture, and other examples of absolute measure of dispersion are mean deviation, range and quartile deviation. Another measure of dispersion is the relative measure. This will give the degree of variation. Example, coefficient of variation. This relative measure is calculated based on the absolute measure. Each absolute measure will be having a relative measure. These measures of dispersion give an idea of homogeneity or compactness or heterogeneity, scatteredness of the distribution. And in absolute measure of dispersion, it gives the amount of variation, and this cannot be used for comparison between two variables. That is why there is a need for relative measure of dispersion. It gives the degree of variation, and this can be used for the comparative study of the characteristics of two or more series. Coefficient of variation is a relative measure based on standard deviation. To Professor Carl Pearson, a famous statistician, coefficient of variation is the percentage variation in mean, standard deviation being considered as the total variation in the mean. It is calculated using the formula coefficient of variation, in short we'll write it as CV, is equal to standard deviation of the distribution divided by mean of the distribution into 100. For comparing the variability of two distributions, we compute the coefficient of variation for each distribution. Coefficient of variation is based on the standard deviation, which is measure of dispersion. A distribution with smaller coefficient of variation is said to be more homogeneous or compact or uniform or less variable than the other. But a distribution with greater coefficient of variation or higher coefficient of variation is said to be more heterogeneous or more variable than the other one. Let us see an example. If n is equal to 10, n means the number of elements in a distribution is 10, and the distribution's arithmetic mean is 12, and sigma x square, sum of the squares of the observations is 1530. Find the coefficient of variation. So for coefficient of variation, we are given with n is equal to 10 and arithmetic mean x bar is equal to 12 and sigma x square is equal to 1530. According to the formula, coefficient of variation is equal to standard deviation of the distribution divided by arithmetic mean of the distribution into 100. Now here we don't have the standard deviation, so first from the given data we have to find the standard deviation. By direct method to find the standard deviation sigma is equal to square root of sigma x square divided by n minus x bar square. So sigma x square is given, x bar is also given, and n is the total number of elements 10, that is also given. We can calculate the standard deviation as square root of 1530 divided by 10 minus 12 square is equal to square root of 153 minus 144, that is square root of 9 is equal to 3. So standard deviation of the given distribution is 3. Now we have standard deviation and the mean. So we can calculate coefficient of variation by substituting the values in the formula for coefficient of variation, as coefficient of variation for the given distribution is equal to standard deviation is 3 divided by mean is 12 into 100. So we'll get 25 as the coefficient of variation. Another example, the arithmetic mean of runs scored by 3 batsmen X, Y and Z in the same series of 10 innings are 50, 48 and 12 respectively. Standard deviation of their runs are 15, 12 and 2 respectively. Who is the most consistent of these 3 batsmen? If one of the 3 is to be selected, who will be selected? So for this, we have to find the coefficient of variation, and the most consistent player is the one who is having the less coefficient of variation. So we are given with the mean of 3 batsmen. Let x1 bar, x2 bar and x3 bar be the means of x, y and z players, and sigma 1, sigma 2, sigma 3 are the standard deviation of the runs scored by x, y and z. We are given with n as 10 and x1 bar as 50, x2 bar as 48, x3 bar as 12. Sigma 1 standard deviation of x as 15, sigma 2 12, sigma 3 as 2. Now, according to the formula, coefficient of variation is standard deviation divided by mean into 100. So for the first player, the coefficient of variation of runs scored by x, the first player, is sigma 1 by x1 bar into 100. So substitute the values, will get 15 by 50 into 100 is equal to 30. So the coefficient of variation of runs scored by second person, sigma 2 by x2 bar into 100, 12 by 48 into 100, which is 25. Now for the third one, coefficient of variation is sigma 3 by x3 bar into 100 is equal to 2 by 12 into 100, which is 16.67. So the consistent player is the one who is having the less coefficient of variation. So here of these, here 30, here 25 and here 16.7. So the last player or the batsman Z is the more consistent player. So we will be selecting him, and the decision regarding the selection of the player may be based on some other conditions also. One is the player should be consistent, and other one is the average runs scored by the batsman must be high. So here the average runs scored by the players are 50, 48 and 12. So of these, the highest is scored by x. So if we wanted to select a player whose score is the highest, we will select x, and if we want a consistent player, we will select z. Another example, the coefficient of variation of two series are 75% and 90%, and their standard deviations are 15 and 18 respectively. Find their arithmetic means. So we are given with coefficient of variation of the first series is CV1 is equal to 75, and standard deviation of the first series sigma 1 is equal to 15. And for the second series, coefficient of variation of the second series 90 and standard deviation of second series 80. So we have the equation, or we have the formula. According to the formula, coefficient of variation is standard deviation by mean into 100. So we are given with the coefficient of variation and the standard deviation. So from this we can calculate mean, as mean is equal to standard deviation divided by coefficient of variation into 100. So substitute the values, we will get mean for the first series is standard deviation of the first series, which is 15, divided by coefficient of variation 75 into 100 is 20. And for the second series, mean is equal to standard deviation is 18 divided by coefficient of variation 90 into 100 is equal to 20. So both the series are having the mean 20. Another one, if 20 is subtracted from every observation in a data set, then the coefficient of variation of the resulting data set is 20%. If 40 is added to every observation of the same data set, then the coefficient of variation of the resulting set of data is 10%. Find the mean and standard deviation of the original set of data. So here we are given with an original set, and for each of the observation we are adding 20. Then for the new set we will get the coefficient of variation as 20, and for the initial data set we are adding 40 to each observation, 40 to every observation, then the coefficient of variation is 10. We have to find the mean and standard deviation of the original data set. Let x bar be the mean and sigma x be the standard deviation of the original data set, and sigma x is equal to sigma. Let u is equal to x minus 20. That means subtracting 20 from every observation of the original data set. So if we subtract 20 from every observation from a data set, bar is equal to the mean of the new data set is equal to x bar minus 20. And since the standard deviation is independent of change of origin, the sigma u is equal to sigma x is equal to sigma. So there is no change in the standard deviation if you change the origin of the data set. That is why we have sigma u is equal to sigma x is equal to sigma. And we have v is equal to x plus 40. Then v bar is equal to x bar plus 40. That means add 40 to the existing data set's mean. And since the standard deviation is independent of the change of origin, the standard deviation of the new set sigma v is equal to sigma. So here, after changing the values of the data observations by a constant 20 in the first set, there is no change in the standard deviation. With coefficient of variation of u set is 20, that means sigma u by u bar is into 100 is equal to 20. That means sigma u is equal to sigma and u bar is equal to x bar minus 20. So substituting these values will get sigma by x bar minus 20 into 100 is 20. Now 100 sigma is equal to 20 into x bar minus 20. This is the first equation. Now we are given with coefficient of variation of v is equal to 10. That means sigma v by v bar into 100 is equal to 10. That means sigma by x bar plus 40 into 100 is equal to 10. From this we will get 100 sigma is equal to 10 into x bar plus 40. This is the second equation. Now from equations 1 and 2, these both the left hand sides are equal. So we can write 20 into x bar minus 20 is equal to 10 into x bar plus 40. So from 1 and 2 we can write like this. Now by solving this we will get x bar is equal to 80. Substitute x bar is equal to 80 in the first equation. We will get 100 sigma is equal to 20 into 80 minus 20. So we will get sigma as 12. Another example, a study of BSc examination results of 1000 students in 2010 gave the mean grade as 78 and the standard deviation as 8.0. A similar study in 2015 revealed that the mean grade of the group as 80 and the standard deviation is 7.6. In which year was there the greater absolute dispersion and relative dispersion? So here absolute dispersion means find the standard deviation. Relative dispersion means find the coefficient of variation. Absolute dispersion is the standard deviation and in 2010 it is given as 8.0. In 2015 standard deviation is 7.6. Of these, the highest value for standard deviation is in 2010, which is 8. Now for relative dispersion, which is coefficient of variation, can be calculated with the formula standard deviation by mean into 100. Substitute the values. In 2010, coefficient of variation is 8 by 78 into 100 is 10.256, and in 2015 coefficient of variation is 7.6 divided by 80 into 100 is equal to 9.5. Of these, the coefficient of variation is high here in 2010, and a lower value of coefficient of variation means the series is more consistent. Hence, from 2010 to 2015, the average performance of the students has improved and they have become more consistent. That is given from the lower value of coefficient of variation. Measure of dispersion give an idea of the homogeneity or heterogeneity of the distribution. And there are two types of measures for absolute measure of dispersion and relative measure of dispersion. Absolute measure of dispersion is standard deviation and coefficient of variation is a relative measure of dispersion based on standard deviation. So for comparative study of the characteristics of two or more series, we can use coefficient of variation, and it is found using the formula standard deviation divided by mean of the series into 100. With this, we are concluding this session. Thank you.